Hey guys, it's Mr. Wigand. Today we're going to look at exponential functions and we're going to compare different exponential functions, see how they change. All right, so essentially we're looking at an exponential function in the form of y equals a times b to the x power. The graph that we're looking at right here is essentially y equals 1 times 4 to the x power. So a is 1 and b is 4. Now I'm going to use this slider right here, and right now A is set at 1. I'm going to slide it up. Now we're going to see what happens to the graph. So as A gets bigger, you can see now the red line kind of going up. So imagine this graph that we're looking at. Imagine this is almost like a string, and I've got my hand holding the top of it. And if I were to pull that string up, it would slide over, or it would appear like it's sliding over this way. So if I was trying to stretch it vertically, it would move to the left. And that's essentially what's happening here. I'm pulling it up and it's moving left. So we would call that a vertical stretch. So if you notice, as your A values increase, then your graph is essentially stretching even more. So one of the ways that we compare exponential graphs is with a vertical stretch. So if it's moving to the left like that, you're really kind of pulling that string up, and that's making it stretch vertically, and that happens when A gets larger or greater than 1. All right, let's try getting smaller than 1. So now I'm going to go down, and it goes to the right. Now, think of this as a string again. If I was pushing down on it, it would be pushing it to the right. So this would be a vertical shrink, because vertically I'm going downward now. So if I go back to A equal to 1, there it is. If I make it smaller, it's going further to the right, meaning that I'm pushing down on the string, which would be a vertical shrink. All right, so if you noticed, I really was going lower than 1, but I never actually got to 0. So let's see what happens if I go past 0. Oh, now look at it. So let me go all the way to -1. If I look at -1, what I just did was I took our original y equals 1 times 4 to the x power and I reflected it over the x-axis. So now it's symmetrical with the x-axis, same exact graph just on the other side of the x-axis. So we call that a reflection in the x-axis. And that happens when your a value becomes negative. Now, that's when a is -1. It's exactly the same, just reflect it. But look, as I get smaller, and -2, -3, then there we are with that vertical stretch again. So really, before when I was saying the a value gets larger, really think about it as the absolute value gets larger, because this graph, the way it is right now, or even if I keep going, not only is it a reflection in the x-axis, it is also a vertical stretch. Okay, so you can have a combination. You can have vertical stretch, a reflection in the x-axis, you can have vertical shrink, and a reflection in the x-axis, you can have more than one thing. All right, let's set this back to 1. All right, let's take a look at this now. We have y equals 1/2 times 4 to the x power. Imagine, what do you think is going to happen here? You know, I don't have a 1 here in the a value. I have a 1/2. So I have that number that's less than 1, or in between 0 and 1. And there it is. It's moved to the right, so that would be a vertical shrink. All right, let's take a look at this one. Y equals 10 times 4 to the x power. Notice I'm keeping 4 to the x power the same in all these. I'm just changing the a value. So now we have that number bigger than 1. Think about what might happen here. Where'd it go? There we go. Nope. There we go. And it moves to the left, or a vertical stretch. Remember, when I pull that string up, it kind of moves the string to the left. So that a value being bigger than 1 gave me a vertical stretch. All right, now we have y equals -1 times 4 to the x. So we have that negative, and that's where we get that reflection in the x-axis. And since it's the same, the absolute value of negative 1 is the same as 1, that's all it is. There's no stretch or shrink. Let's take a look at this one. We have y equals negative 1/4 times 4 to the x power. So I know that negative is going to make it a reflection. Is it going to be a shrink or a stretch? And it turns out to be a shrink because it's moved to the right. So that fraction, the absolute value of negative 1/4 being 1/4, made it shrink. And then the last one, y equals negative 8 times 4 to the x power. I know the negative is going to reflect it over the x-axis. The absolute value being a number bigger than 1, I think that's going to be a vertical stretch. And it is, because it moved to the left. All right? So we have vertical stretch, we have vertical shrink, we have reflection x-axis, and we have combination of them. All right, so let's finish up here. Exponential growth, we're using the equation y equals a times b to the x power. When a is greater than 1, you will see a vertical stretch. When a is between 0 and 1, that's when you're going to see a vertical shrink. And don't forget, vertical stretch moves it to the left, vertical shrink moves it to the right. And then when a is less than 0, a negative number, you will see a reflection in the x-axis. Or you can see combinations of a reflection and a stretch or a shrink. All right, there you go, guys. That's exponential functions and the graphs and comparing them. Good luck.